today let's say that transient. Transient means that the changing of the current value and the voltage value will be changing. Especially when you check the current in the resistor current is ever constant because of it. Only that you change the resistance value of supply voltage, the resistance current will be changing. But when you check the inductor or the capacitor, but resistor and the capacitor inductor is different. When you check the resistor, current will increase instantly. As well as you increase the voltage, the current also will increase. So this is the voltage flow and the resistor. Voltage flow, and then you charge the resistor. So current I, voltage V. So the V voltage may increase, the current I also will increase. V increase or I increase. So this is for the resistor current. So this is for the resistor. But for the capacitor, this is a supply here. So this is a switch. When you switch on, the capacitor voltage will not increase instantly. It will follow the graph. So capacitor charging can also use the capacitor voltage will be like this. So this is for the you increase the current I, capacitor voltage VC. So this is VC, this is current I. Will follow like this. And this is for the originally off and then you on the switch. And originally on the switch and then you off. So this saturation, the capacitor voltage waves are going down. So capacitor voltage VC and the tie. VC will going down by the discount. So this is for the capacitor. And similarly for the inductor. So inductor you switch on the switch to the inductor. So this is a pure inductor. The current I here. So when you switch off, the current I increase also gradually follow. So this is time and the current I. The current I is very gradually follow by this graph. And also when you switch off, so this is another here. Current is going down by this graph. So this is time and the current will follow this way. So this is for the relationship of the properties of the resistor, inductor, and the capacitor, and the time of the charging and the discharging. So because of this one, you can also calculate the charging current. The charging current for the capacitor can also be calculated. This is a capacitor charging current. The charging current IC is equal to IC is a charging current. For capacitor. So charging current you can calculate. IC equation is equal to the supply voltage E. So in this case, IC and the capacitor and you make the resistor in CD and then you can find the charging current. So this is for the voltage is E and resistor is R and capacitor is C. And then you switch on the circuit. So resistor is R, capacitor is C. Then you switch on the circuit. You switch on the circuit and you can calculate the IC. IC means charging current. IC is a charging current. So charging current IC you can calculate. The formula is equal to the E power R into E power minus T by RC. So this is for the charging current can be calculated by this formula. So it's a time constant. So this is equal to R multiplied C. So this is also you can calculate IC is equal to E bar R E power minus T by tau. So by this way you can calculate this circuits are we can call the transient circuit. Transient circuit means when you switch on and switch off, the current voltage their properties, they follow the different behavior. When you switch on the resistor, as soon as you increase the voltage, current will increase instantly. But for you charge the capacitor, although you increase the time, the current will follow the distance exponential graph. Similarly, when you switch off, the voltage will go down crossing the exponential graph. Similarly for the inductor, when you switch on the inductor, the current will follow the exponential graph. Switch off, current will also follow, go down, crossing the exponential graph. So those are the transient characteristics of the resistor and the capacitor. At the time of the switching on and switching off, the behavior of the circuit, we study the behavior of the circuit. Those are the transient characteristics. Okay, now we look at the one voltage resistor and the capacitor in series to the supply voltage E. In this case, IC is the charging current. So IC can be calculated. When you switch off, IC can be calculated. The formula is equal to the E divided by R multiplied with E power minus T by RT. So this is the behavior of the charging current formula. In this case, tau is equal to the time constant. This is equal to RT. So we can calculate the charging current IC is equal to E by R multiplied E power minus T by tau. So this is for the capacitor charging current. Right? So VC is equal to the formula is E multiplied 1 minus E power minus T by RT. So this is the voltage, charging voltage. The formula is supply voltage E 1 minus E power minus T by RT. So this is for the charging voltage we can calculate by this formula. Okay, this one is our final mathematical expression for the transient behavior of the VC, IC, VR for the given circuit. Firstly, we calculate the VC. VC formula is when you switch off, the VC formula you can calculate. VC formula is E multiplied. I have already given you the 1 minus E power minus T by RT. So this is for the voltage of VC. So capacitor voltage VC. Capacitor voltage VC can be calculated by the formula. The VC is equal to E multiplied 1 minus E power minus T by RT. So in this case, resistor capacitor is already given, so we have to substitute the E. So E is equal to the 40 volt, 1 minus E power minus T by resistor value. Resistor value R is 8 kilo ohm, 8 into 10 power minus 3, then 10 power 3. Multiply with capacitor value 4 microfarad, 4 into 10 power minus 6. So then you can calculate for the VC. So that will be the so this began as 40 into 1 minus E power minus T. So if you solve this one, that will be the T divided by 32 into 10 power minus 3. So this is 4. So this is for the VC we can calculate. IC. IC value. So IC value is normally if you got the only resistor, the voltage divided by the resistance. So this is the IC current you got. So but this one is this resistor if you got the only resistor, voltage by the resistance. But this one is resistor in series with the capacitor. So the capacitor transient also impact on the current. So therefore the IC formula is E divided by R into E power minus T by tau, T by RT. So this equation. So this is equation for the IC. And that one is the equation for the VC. So this one we can substitute here. E is 40 volt. Then the resistor value R is 8 kilo ohm. 8 into the 10 power 3. And E power minus T divided by RT. So R is 8 into RT we only calculate. This is 32 into 10 power minus 3. So by solving this one you got the IC current. IC current will be the 5 into 10 power minus 3 multiplied with E power minus T divided by 32 into 10 power minus 3 ampere. So this is for the capacitor current we can calculate. And also, we also need to calculate for the voltage across the resistor, VR. The VR formula is, the equation is given by E multiplied E power minus T by RT. So this is for the VR formula. So we substitute the VR formula here. So the E is 40 E power minus T divided by 32 into 10 power minus 3. So that will be the voltage formula. So by solving this one, you can calculate for the BC, IC, and the BR. Charging calculation. Loading and charging. For the charging of the capacitor, so in series with the resistor, we use the formula. So charging voltage can be calculated E multiplied 1 minus E power minus T by RC. Charging current IC also calculate, so E by R multiplied E power minus T by RC. And also the voltage across the resistor, the formula is E multiplied E power minus T by RC. So those are the resistor and the capacitor series circuit for the charging die. So charging die, the voltage grew, current grew, and can be calculated by those formulas. Okay, this one, first one we already talked about the charging. Now we talk about that the charges are RC circuit. So this is the switch. This switch is will be off. So this is resistor R. The voltage flow is a plus or minus a VR. And also the capacitor C. The voltage is a plus or minus DC. So we can calculate. So this is for the discharging. So this is for the discharging. So this is we connected to voltage is a E. So when you on the switch, there is a discharge. So discharge you can calculate. The discharging current is a BC. Discharging voltage and charging voltage different. Charging voltage is a BC is equal to E multiplied 1 minus E power minus T by RC. But for the discharging voltage is equal to E multiplied E power minus T by RC. And so also the charging current. Charging current you can calculate is E by R, E power minus T by RC. The discharge also, the equation is E power, E by R, E power minus T by RC. So this is for the discharging. Discharging current, you can calculate for the load capacitor. And also the voltage across the resistor. Voltage across the resistor, VR also calculate. VR is equal to E into E power minus T by RC. So this is for the voltage across the resistor. Voltage across the resistor, voltage across the capacitor, and the current discharging, we can calculate by the load formula. Okay, so this is for the circuit here. So voltage is a 10 volt. Originally the switch is located at the T. So and then so located at the 1 position. So in this case, the voltage 10 volt is supplying so resistor R1 is 100 kilo ohm. And also the capacitor C is a middle branch. This is a 0.05 microfarad, and resistor R2 is a 200 kilo ohm. So when the switch goes to the position 1, so this is the resistor R1 and the capacitor C are connected in series. And the position 2, that will be the off circuit. Off circuit this position 2 position, that will be the off circuit. When the switch are connected to the position 3, so there is the resistor R2 and the capacitor will be connected in series. So for the circuit behavior, at the time of the switch is connected at the position 1, so the current will flow starting from the E, the passing through the R1, passing through the capacitor, so the capacitor will be charging. And then the at the middle position 2, this circuit is a totally disconnected circuit. So at the position 2, the capacitor will retain the voltage. At the time of the position 3, so the capacitor will discharge the current into the resistor R2. So this is the circuit behavior. At the position 1, resistor R1 and capacitor connected in series across the voltage supply. So the current will flow into the capacitor. So the capacitor is charged. So the capacitor retains the charging voltage. And the switch goes to the position 2. So this is the circuit with the off circuit. Because this position, the circuit with the off circuit. So the capacitor still will retain is a charge, the electromagnetic charge, electric charge, and then the switch goes to the position 3. So the capacitor there is no longer connected to any supply. The capacitor and resistor are connected. So the capacitor will discharge its electric charge into the resistor R2. So this is the behavior of the circuit. Okay, so at the time of the position 1. Position 1 will be the capacitor is charging the saturation. So you need to calculate the capacitor charging voltage. So in the program now we have already given the capacitor charging voltage. For the capacitor charging, VC is equal to E multiplied 1 minus E power minus T by RC. So this is for the capacitor charging. So this is the switch at the position 1. Switch at position 1. So this is what is the capacitor charging. So switch at the position 1 is the capacitor charging. So we can calculate charging voltage. VC is equal to E multiplied 1 minus E power minus T minus tau. So we can calculate. So VC is equal to E multiplied 1 minus E power minus T by tau. So this is VC. So that we can calculate for the tau. So in this case, we substitute here E is a tempo. 1 minus E power minus T by tau. Tau is R1 multiplied T. So then we use a 10. 1 minus E power minus T RC. So R1 minus T, R1 is 100 into 10 power 3 kilo ohm. Capacitor is 0.05 into 10 power minus 6. So by this way you can calculate for the VC. So VC is equal to the 10 multiplied 1 minus E power minus T divided by 5 into 10 power minus 3 the volt. So this is for the VC. So this is for the capacitor charging phase. Okay, D. So at the time also we have to calculate for the IC. So IC means that when the switch is connected to the position 1, capacitor is being charged. So this current IC also the charging current. The charging current we can calculate by the formula. The formula is E divided by R. E divided by R, E power minus T by RC. So this is the equation. So in this case, at the time of the position 1, the resistor is R1, capacitor is C. So that for the place of the RC, you have to substitute the R1 into C. So this is for the capacitor charging current you can calculate. IC is equal to E by R. E power minus T by R1C. And you substitute here. E is at 100 volt and E is at 10 volt. The R1 and resistor is R1. So resistor R1 is 100 kilo ohm. 100 into 10 power 3. E power minus T by R1C. So R1 is at 100 into 10 power 3. Multiply capacitor C. C is 0.05 into 10 power minus 6. So then you can calculate for the RC. So this result is current will be 0.1 into multiply 10 power minus 3 equal minus T divided by 5 into 10 power minus 3. So this is for the current IC we can calculate for this current. So this is for the B. And for C. So you need to find the mathematical expression for the response of VC and IC. So that if the switch is thrown in the position 2 at the 30 milliseconds. So at the position 2, the VC is still retained as a tempo. So the VC is equal to tempo. Because the tempo charge the capacitor. So capacitor voltage is tempo. At the C. So at the C position, at the switch is at the position 2, then we use totally off. So the tempo is charged at the capacitor C. So the capacitor VC is a tempo. IC is a 0 because of this one is at the position 2. All the circuit is off. All the circuit off and no current will flow. So the IC is equal to 0. This is for the answer C. And the D. He means find the mathematical expression for the voltage VC and IC. If the switch is thrown into the position 3 at the 48 milliseconds. So the 48 milliseconds, the switch is thrown into the position 3. So we can also calculate this position here. So in this case, position 3 is a discharge position. So this is for the switch at the position 2 is the circuit off position. Position 3 is a discharge position. So switch at the position 2. So this is the off position. And the switch at the position 3, that will be the discharge. Switch at position 3. this is a teacher position. Teacher position, so in this case you can calculate the current IC. The voltage VC you can calculate E into E power minus T by the tau. So you can calculate. So in this case, at the position 3, the resistor will be R2 capacitor is C. So this is you can calculate. So this is DC is equal to 10 into E power minus T divided by R2 into C. So 10 E power minus T. The R2 you can calculate 200 kilo ohm. 200 into 10 power 3 into C. So from here you can calculate that will be 10 E power minus T divided by 10 into 10 power minus 3. So E power minus T divided by 10 into 10 power minus 3. So this will use 4. So the PC. And also IC you can also calculate. IC is a discharge. Discharge means the discharge current is a negative. Negative voltage is E divided by R2. So E power minus T by the tau. So this is a minus. Voltage is original voltage is 10 volt. R2 is 200 into 10 power 3. E power minus T by the tau is R2 into C. So tau is 10 into 10 power minus 3. So the current I. So this is by solving you can calculate the minus 0.05 into 10 power minus 3 E power minus T by 10 into 10 power minus 3 ampere. So by this way you can calculate for the current I. Wait a minute, the graph. So first is a BC graph. So what is the right time is this? This is the value is a BC. So first is a discharge phase, a charging phase and a constant value and a discharge. So the from is given from the 0 to the 30 millisecond, and this is the charging phase. So this is 0 to the 30 millisecond. And 30 to the 40 millisecond, so this is a constant. And also after the 40 millisecond, there will be the current with the discharge. So this is for the BC and the current I. BC and the T is a relationship. Another one is the IC and the T is a relationship. So at the first position will be the current is going down. So this position. And then the second position is the current is 0. Some position current is the opposite direction and we go like this. So this is for the IC. So this is for the 30 millisecond, the current going down, and 30 to 48 millisecond, current 0 and 48 to above, the current with the opposite direction. So those are the color, voltage current, the characteristic, and the graph color is more like the transient circuit. This program. So this program is this circuit here. So firstly, it is connected at the switch 1, and so this is the position, and another with the switch 2 position. So the final mathematical expression for the transient behavior of the voltage VC and the current IC. So switch position 1 at the t equal to 0 second. So at the position 1, we have to find. So in this case, you have to find the Darwinian equivalent circuit. Because of the why we need to find the Darwinian equivalent circuit is the one that resistor. So previous problem is simple. You got only one resistor. Only one resistor, one capacitor quantity is series, so that you directly substitute. But here is the resistors are complicated because of that there are three resistors. R1, R2, R3, they are connected. So when the switch position is this one, the whole R1, R2, R3 are that need to be provided. You have to find the equivalent resistance. This resistance and the capacitor C are connected in series. So that in the place of the resistor R, you need to substitute the RDH. So this is the Darwin equivalent resistance. So this is the only difference between this problem and the previous problem. Previous problem there is only one resistor value, but this problem there is there are three resistor values, R1, R2, and R3. So that at the position 1, the resistance is a Darwin equivalent resistance. So you have to determine the Darwin equivalent resistance. Okay, how to determine the Darwin equivalent resistance? to find a traveling equivalent circuit, you need to get a source. So get a source means that voltage source are to be short circuited and current source are to be the open circuited. So this program voltage source is only E. So you have to make the short circuited. The voltage source is short circuit. And so the resistor R1 is at 50 kilo ohm. And resistor R2 where it is 30 kilo ohm. And resistor R3 where it is 10 kilo ohm. So this circuit here. So this is the RTH. This RTH and capacitor are in series. So that when you make the short circuit, you can see that the R1, R2 in parallel and the series with the R3. So the RTH you can calculate the R1, R2 parallel plus R3. So R1 parallel R2 plus R3. So then you can calculate the RTH. So the R1 60 minus R2 30 divided by 50 plus 30. The R3 is at 10. So by solving this further RTH we got, that will be the 30 kilo ohm. So this is the RTH. So EDH you also need to calculate. So voltage, in this case this voltage here. The voltage VCS usually we use as E by E multiplied 1 minus E power minus C by tau, or the I is E by R1 E power minus C by R1C. This E. This E is the previous program is simple. This is the source voltage because of the source is directly connected across the resistor and the capacitor. But this program does not directly connected because of this source and resistor R1, R2 and capacitor so we connect like this. So in this case to be able to calculate, so the voltage is also the EDA need to calculate. So instead of the P, you have to find the traveling equivalent voltage EDA. So the EDA you can calculate here. So E1 is this terminal voltage. So this is a 21 volt. And the resistor R1 60 kilo ohm and resistor R2 30 kilo ohm and resistor R3 10 kilo ohms are connected. And voltage across this one will use the EDH. So EDH you can calculate. So the EDH how to calculate means that the voltage 21 volt. So you see that the voltage across the EDH. So voltage across EDH you can calculate. So voltage across the R2 is similar to the EDH because of this line is the R2 is the off. So the voltage of R2 is the same as the EDH because this circuit is off. So then we have to find the voltage across the R2. So VR2 you can calculate. So crossing the potential divider theorem, E multiply R2 divided by R1 plus R2. So this is the VR2. E is a 21 volt. Multiply R2 is a 30 kilo ohm. Divide R1 plus R2 means 50 plus 30. So 21 multiplied 30 divided by 50 plus 30. So by solving this one, EDH is VR2 is 7 volt. VR2 7 volt, then you can calculate EDH. It's also the VR2 is also equal to 7 volt. So we got the EDH we got. And after you got the EDH and the VR2, you will be able to calculate the VC. So the program asks the VC. The VC you can calculate formula. The VC the general formula is equal to the E multiplied 1 minus E power minus C by tau. And this is for the only supply voltage. For the traveling voltage, equivalent voltage, VC is equal to EDH multiplied 1 minus E power minus C by the tau. So we substitute EDH as 7 volt here, 1 minus E power minus C by tau. Tau is RTH into C. So this is a 7 into 1 minus E power minus C divided by RTH is to be substitute here. 30 into 10 power 3. Multiply, capacitor value is 0.2 microfarad. 0.2 into 10 power minus 6. So that's equal to 7. So this by solving this one, you got the thing is 0.233 into 10 power minus 3. So E power minus T divided by the 6 into 10 power minus 3. So this becomes our voltage. VC we can calculate by this way. So this is for our first expression. And then second, C. Because we have to find a mathematical expression of the body BC and the current IC as a function of time. If the switch is thrown into the 2 and the T is at 9 milliseconds. So the second position, the switch is connected to 2. So that way is the discharging. First position is the charging for position. First position is charging position and the switch at the position 1. Switch at position 1. So this is the charging. So at the position 1 charging, therefore that we have to utilize equation now. VC equal to EDH into 1 minus E power minus T by tau. This is for the charging. And second position, say we connected to the position 2. The position 2 will be there. This is the discharging. So straight at position 2. So this is the discharging. So for the discharging, you have to utilize the discharging formula. The discharging formula we have already given. The VC is equal to E multiplied E power minus T by tau. This is the discharging. This is the discharging position. The discharging positions are we have to calculate VC equal to the voltage into the. So in this case, our as a position 2, you have to calculate the VC. So when it's thrown into position 2 as a 9 milliseconds, 9 milliseconds means that this is that you have to charge up to the 9 milliseconds. 9 milliseconds means you have to charge the body up to 9 milliseconds. Charging body up to 9 milliseconds. Charging body up to 9 milliseconds. So charging body 9 milliseconds, you need to calculate. The VC formula is EDH into 1 minus E power minus T by tau. So that in this formula, you have to substitute the 9 milliseconds. So VC is equal to the you call it as 1 minus 7 into 1 minus E power minus T by so 6 into the 10 power minus 3. So H T equal to 9 milliseconds. So that way VC is equal to 7 into 1 minus E power minus 9 into 10 power minus 3 divided by 6 into 10 power minus 3. So by solving this one, you call the voltage VC. So VC you can calculate. So that way be 7 into 1 minus E power, so this is minus 3. So by solving this one, calculator, you use this one, so you calculate this way, be 5.444 volts. So you see, at 9 milliseconds, we got the current like this. And also, IC at 9 milliseconds. So this is a VC at 9 milliseconds. Also, IC 9 milliseconds. So IC formula you calculate. IC is a EDH. We call the thing is 0.233 into 10 power minus 3. Multiplied with E power minus T by 6 into 10 power minus 3. So this is the IC. So we substitute here 0.233 into 10 power minus 3. Multiply E power minus 9 into 10 power minus 3. And divided by 6 into 10 power minus 3. So there is 0.233 into 10 power minus 3. Multiply E power minus 3. So by solving this other IC at the 9 milliseconds is 0.052 milliampere. This is the IC 9 milliseconds. AC 9 milliseconds and the IC 9 milliseconds we calculate. And after 9 milliseconds we discharge. So discharge is that this original voltage is the voltage at the 9 milliseconds is the original voltage. So that you can use this voltage as a E. For the discharge, the formula is given. VC equal to E into E power minus T by RC. IC equal to E by R, E power minus T by RC. Those are discharging. So discharging voltage, this in the place of E, at the time that T is equal to 9 milliseconds, this is discharging. So the voltage at the 9 milliseconds is E. You have to substitute. And in the new resistor is only the R4 and capacitor this one. So we calculate for the discharge voltage. So this is what is discharging. This formula is E into E power minus T by RC. In this case, VC is the VC 9 milliseconds into E power minus T by RC. So you substitute. BC90 divided is that we got the data 5.44 e power minus p by RT. So resistor is the R4. R4 into C. So that will be the 5.44 e power minus p. Resistor R4 you substitute. So R4 value is the 10 kilo ohm. 10 into 10 power 3. And capacitor C value is 0.2 microfarad. 0.2 into 10 power minus 6. So by solving this one, you got the BC. The BC will be the 5.44 e power minus p by 2 into 10 power minus 3. So this is the volt. And also that we also need to calculate for the IC. IC formula is E by R minus E power minus C by RT. So in this case, so this is VC is 9 millisecond by R to E power. So this is a negative value minus C by R4C. So you substitute here. So that will be the VC 9 millisecond. So this is the minus 5.44. 5.44 divided by resistor value is that we already calculate 10 kilo ohm. 10 into 10 power 3. E power minus P by R4C. So R4C is 2 into 10 power minus 3. And then you get for the current IC. So current IC we calculate. So that will be this formula is minus 0.054 into 10 power minus 3. So IC you can calculate is minus 0.054 e power minus T divided by 2 into 10 power minus 3 ampere.